as people trickle into this space, I just want to take a couple moments and introduce myself and introduce you to the speaker and thank our collaborators in this process. So for those of you who are new to the series or do not know who I am, my name is Dr. Jessica Stansberry. I am the Director for Teaching and Learning Excellence with the University of Baltimore with our Center for Learning, Teaching, and Technology. Today, I also want to take a moment and thank our collaborative partners. So thank you to UMBC and to Johns Hopkins and to the Center for Entrepreneurship and Innovation within the University of Baltimore as well. They are all collaborators with us in this series. And this is our second semester putting the series on. So we're really excited for this. Today, we have an exciting guest. His name is Dr. Vince Kellen, and he is the CIO for UC San Diego, and he has been in higher education for the last 22 years. And I'm going to turn it right over to him because he has some exciting things to share with us today. Vince?
And thank you so much. And I'm going to share my screen, and I'm going to be talking about looking at AI, but from a slightly different perspective. And so what we've been doing internally is thinking about AI in terms of metabolism, and metabolism of, human and animal metabolism. So I've titled this one here, The Metabolism of Knowledge in AI. And we're going to talk about specifically how we're applying it within our AI platform at UC San Diego, which we've affectionately called Triton GPT after our mascot, the Triton. First, a little bit our strategy. We've been focusing our efforts in AI on pursuing vertical AI, meaning AI that's tailored or specific to our institution, mainly content that's very much related to our institution. So, and so we think that makes it competitive and focuses on our proprietary content. You can also think of AI as, if you got horizontal AI, that's like giving somebody a license to the general AI tool and saying, here, go at it. That's like sort of dropping a $30 a month screwdriver on somebody's desk and say, go ahead and use it now. What we're doing is we're ingesting a whole bunch of UC San Diego content, and now we're developing agentic systems underneath that to help solve very specific UC San Diego problems. Along the way, we're discovering that once you have the AI really working with your content, your data, you don't need a big, expansive model. So smaller models can work pretty well. And so we've been certainly testing and using some of that concept. We are leveraging open models and open source software wherever possible. And of course, given the market volatility, we're investing in options. So we just don't have one model. We got several models within our platform. By the way, our entire platform runs on-premise in our supercomputer center using NVIDIA H100 chips for now. We'll actually be downsizing some of our chips, not upsizing them, because inference is much more efficient. As time goes by, it's becoming more and more efficient. This enables us to open up the AI platform to all 38,000 employees at very, very low cost to the institution, and then soon to our student population. And there's a couple articles here you can refer to that discuss some of these topics. I'm not going to go over this slide here in too much, but it's a visual representation of horizontal AI that cuts across multiple organizations versus vertical, where it's really could be a vertical like a discipline, let's say the chemistry discipline, but it's really meant to also mean for that institution. This is a screenshot that looks at our current Triton GPT platform. Very simple. It's just a dialogue interface that lists some of the assistants, we call them. You think of as GPTs. This platform is powered by the answer, an open source tool that's actually brought to market by a company called Onyx. They were students out of UC San Diego a few years back, and they received first and second round funding. Now they're off and running. It's a tool that's really designed to help us bring data into the environment, and also serves as kind of a very friendly agentic, I won't say agentic, but assistant development environment for our developers. but also for the user, the ability to create chats, share them, save them, upload content, all the things you would want to do in these interface in these AI platforms that are out there. This chart is an eyeful, and I'm not necessarily going to expect you to read everything here because I'm going to talk over it. But this is a way that we're using to think about how our AI platform actually works. And at the core of this are these little molecules here, all sprinkled throughout. We're calling those knowledge fragments. And think of a knowledge fragment as a phrase or a word or a sentence or two. They float about in this system. And they could be simple things like we interview an expert for, let's say we want to understand how the gender column in our student data warehouse is handled. That expert will tell us. So it might be a short interview, might be some text they write. That becomes a very useful knowledge fragment that is now useful to the AI service because it is additional context, knowledge that we can bring into the system. And that's an example of a small knowledge fragment. But another one might be coming from our structured data services, in this case, our activity hubs, which is our data warehouse environment, as well as the machine learning services in it, for retrieval of rows of data that answer a specific question a user may have. That could be a very large knowledge knowledge fragment. We'll call those knowledge bundles. They're very large. And we also have down here our configurators, people who are creating and manipulating the AI platform behind the scenes and creating agents. Whenever somebody, think of this, whenever somebody types their finger to glory, wherever it is, they are communicating knowledge of some sort. So our configurator is creating the agentic code, which is in our case in Python and in LangChain. That is knowledge in and of itself. So our configurators are trying to think about how, when they do their work, that knowledge can be captured into the system, even to the point where we can have an agent create other agents. And we've started to explore that particular topic. We have other knowledge fragments here, such as things coming out of the LLM inference engine and being returned back to what we call our agentic service, the innards that fronts the user interface for everybody. And those would be very large, we call them knowledge bundles, because the LLM might have 2-3 paragraphs of output that is coming back out. We have other knowledge bundles. We have all, thousands of documents. I think we're over 10, 20,000 documents now that we store in our vector database, which is a database that converts that text into a format that's very suitable for the LLM. And those are all very large knowledge bundles. Now, we think of these knowledge fragments as examples of bits of knowledge that have different forms. So we call those knowledge species. We have, certainly very important to us, is knowledge from experts who help us. We've been developing and have deployed a fund manager coach. This is a system that's designed to help our grant accounting people process transactions and understand policies and rules around it. That's very important knowledge. We've gotten a lot of that in. That comes into this agentic service and can get stored within our vector database or alternatively brought into the dialogue session in the middle of the dialogue session as an embedding. And so those are, we'll call human, knowledge bundles coming from humans, in this case, experts. We have users who interact with our Triton GPT platform, and as they ask questions, those are forms of knowledge too. And so we'll talk a little bit of our data agent, and we have an upcoming EDUCAUSE review article on that data agent. But the concept here is, as a user starts to ask questions of the AI, what they are typing in represents interesting knowledge. If we can take advantage of that knowledge, we can incrementally improve the performance of the output coming out of the AI. And so we call those human dialogue knowledge fragments. Any knowledge fragment that is text-only rendering, it's meant to be read by humans. That's one way to think about a knowledge fragment. Another way to think about it is it has been converted into a vector or an embedding, which is a mathematical numeric representation of that text or that image. we'll call those AI formatted knowledge fragments. So they're specifically maintained and formatted for AI. And then, of course, we have for our configurators here, as they configure the system and manipulate it, those would be called configuration knowledge fragments. For our data warehouse, any data coming out of that, we would call those Activity Hub knowledge fragments. So you can kind of see when you really think about this and you start to follow the flow of knowledge everywhere, you can kind of see it becomes really fascinating. I think this is the application integration environment of the future. In a way, this kind of aligns with a recent meta paper on large concept models, in which rather than the token, meaning a portion of a word being the unit of processing in an AI, in the large concept model that Meta was positioning, it's an entire sentence or an entire concept that is the unit, which is a very different take on this. And in a way, we're kind of leaning into that a little bit, even though under the hood, everything does get converted to tokens as the currency of choice for the LLMs today. And you can kind of see within our environment, we have Llama tools. We got other models in there. You'll see another slide I'll go through in a bit. We aren't doing fine tuning just yet. And the reason is not that we can't, we can. We've actually done some fine tuning, but we're finding the agentic and RAG engineering approaches to be pretty performant for us. And these slides will be available, so we can make them available to everybody so you can pour through them in detail. And this is more of a description of the knowledge species that I just talked about as ways of thinking about how all these bits of knowledge swirl around. This is another rendering of it, but it is now mapped very specifically to our Triton GPT architecture. And we've sort of broken out this architecture now as yes, retrieval augmented generation has been pretty sufficient for us. We don't need fine tuning, especially when you prioritize your content within the flow and you take advantage of agentic style approaches, which we're starting to do. That doesn't mean we won't do fine tuning. We have some thoughts on that, but for now we haven't had the need. We have we'll start with the outer boundary here. This dashed line represents a heavily containerized, almost totally air-gapped environment outside of a few entry points for our Triton GPT platform, which is running in-house. We're running about a tenth of the cost of the current tools from either Anthropic or OpenAI or Microsoft. So our cost structure is very, very low for this. And that's one of the reasons we chose it. We wanted to democratize access. A key element of democratizing access is to remove the cost burden for people in adopting it. Typically what happens is an organization or a university will say, hey, we have these 3 or 4 very valuable use cases, so we'll pay for licenses for those very valuable use cases. If you think of use cases as being Pareto distributed, with the very valuable ones called the fat tail, they're meaningful and important, and we absolutely want to do those. But there's a long tail of use cases that represent much smaller things that each one by themselves might not look interesting. But when you do all of them, they suddenly get very interesting. So we're focused on the long tail of use cases. And to do that, we want to lower the cost as absolutely low as we can, so nobody has to pay anything to use the Triton GPT platform. We've created central funds for it, and it's really not that expensive when you meter out the hardware costs over a 5-year, 6-year life cycle time frame. We've been running GPU clusters in this containerized fashion for over a decade. And so we got a real good handle on how much life we can get out of the hardware and how long it will last. I've been a big proponent of cloud, but at these levels of price differences, I'm not a big proponent of cloud. I like cheap better than cloud. So we have this outer boundary, which represents all the tooling that's in our GPT, in our GPU containerized environment. At the far right here, we have our inference engine, which is running a little interesting caching tool, VLLM, for those who are technically minded. You might want to look it out. It really speeds up performance of inference. We're running Llama models. We've been playing around with the IBM Granite model, Mixtral models, Gemini and Claude. We can call any OpenAI API compatible inference engine that we want out there. But Llama is our workhorse. We have a little bit of inline safety that we are going to be adding to the environment, mainly around Llama Guard, although we're finding it not so useful. It can be useful, but it's not enough bang for the buck just yet. We have out-of-band safety regulation going on here. On a regular basis each day, that we have routines that comb through the input and the outputs from the Train GPT platform to look at the inputs and the outputs from a safety standpoint. We'll talk a little bit about that. We're actually using an ensemble of experts, using several LLMs to evaluate the quality of the output. Our agentic service is partially the Dancer Onyx framework, but it's also LangChain based and Python based. And we're starting to develop a number of agents, these oval light boxes here. And the agents have tools. Tools do something very specific. They're almost like procedural code, really. And typically a tool will connect to this little box here is a connector. And they connect to an external content store of some kind. And so now you can see we've got external content store like Bing search. We include Bing search within our platform. We're about to develop connectors to our Highland OnBase enterprise content management system. We've done some profiling or piloting of building execution software with Quality Build. Can we have within our Train GPT platform the execution of approval of a workflow in Quality Build, for example? And so that'd be the case of how to do workflow routing and approval automatically from the AI user interface, but with a variety of pieces of software. So this will require connectors for each one of those. We already have a connector for our Activity Hub, and that's in play and retrieving data from our data warehouse now. And then we also have a connector via Dancer to 40 plus enterprise content stores like Confluence, Salesforce, SharePoint, Google Docs, etc. That's how we get the bulk of our documents in. So now you can see this architecture and how knowledge is flowing, those little knowledge fragments flowing all throughout here. I already talked about authenticators. These are the green boxes that ensure that whoever is initiating that dialogue, that when they speak to some of these external content stores or when they come in, that they are duly authenticated. We know who they are. So there's a level of regulation already occurring there, authentication. We have agents, those oval boxes, which I shared with you. We have tools, which are bits of Python code that will typically talk to an external system. They can do other things, but typically talk to an external system. They aren't reasoners in and of themselves. An agent is designed to potentially interact with the LLM to help solve problems that it may get, whereas a tool is not. A tool is more mechanical. This yellow box stores. A big question we have with all these knowledge fragments going about is where do we store them? A big place to store them are in our Triton GPT data stores, and our vector database is the biggest one. We do have a configuration database, and that also contains some audit logging, and those are all important for our ensemble of expert safety evaluation. That's the lion's share of our stores of data. But we have business content stores of data. We have Activity Hub stores of data. We have enterprise content stores of data and external stores of data. And then locally, you see these little yellow boxes in tools and agents everywhere. It's quite feasible and perhaps desirable for each of these agents or tools to store bits of knowledge fragments, perhaps redundantly, local to that code or to that agent. And so we're doing that as a form of perhaps caching and resiliency. But sometimes it's very convenient to make little copies of these things locally as part of the processing. I'm going to stop here. It looks like we have some things coming in here. Looks like we're being answered. Let's see, we got a question here. Yeah,
Yes,
we ask an agent a question. The agent talks to the tool and retrieves or sends the information down. Absolutely. Yeah, the agent is the thing controlling the tool. So, all righty. Now this leads to a very interesting question because a very big problem in animal metabolism is homeostasis or regulation. How to keep all of the molecules spinning around in our body within the right quantity and quality at any given point in time. And so this leads to the notion that if you want to build a very quality, secure AI platform, you need to have regulation in many places. And so we're going to first describe why regulate. Well, the first goal of regulation is make sure all the inputs and outputs are operating within acceptable bounds, whatever those bounds are in terms of quality, performance, timing, whatever. In our case, they tend to be quality, but they also tend to be performance a little bit. If the system is too slow, that's out of bounds. The knowledge fragment is not getting into the mind of the user fast enough. And so we might have to change some of these caching techniques in order to get the speed that we want. There are different levels of regulation to be done. We can regulate certainly in the external store. So for example, for the people who are asking data of our activity hubs, questions of our activity hubs, the authenticator knows who they are, and then the activity hub also knows who they are, and the activity hub can then filter columns and rows appropriately for them. So there is this external store regulation that occurs automatically in the external store based on the identity of the individual. But the connector, the tool itself, may actually do a little bit of regulation. So the connector might look for data that doesn't seem right, or it isn't fitting the format that's expected. So there could be a little bit of regulation there. Certainly in the tool, as the tool starts sending the data off to the agent. Agents themselves are big regulators because they'll be asking different questions of the LLM and then weighing responses and assembling a final response back. So in a way, they are a form of regulation. Our LLM safety monitoring, which right now is our ensemble of experts safety model, is a form of regulation. But also as we get further into inline safety, we'll be doing some regulation there. Then, of course, you have organizational policy, where your university may have policies around use of this, and certainly you have regulation there. And you certainly want to make sure that this entire regulatory scheme matches and aligns with organizational policy. And then, of course, you want to make sure it aligns with state and federal law. We view there are two ways to do regulation in a complex AI environment. The first way we know and love well, first order logic, rule-based logic, all the ways we configure our systems today tend to be in that category. And we'll take the activity hubs as an example. When we're retrieving data out of our activity hub, we can filter the data for two purposes. One, security, meaning the user can only get data they have access to, and that means columns and rows. Or probably more better way to think about it is the user needs context relative to their data. So if I'm a fund manager, I come to Triton GPT and say, hey, what are the balances in my account? I don't want the AI platform to keep asking them over and over again, okay, who are you and what accounts are you interested in? That's implied within the context filtering based on the user's account that the authenticator presents to us in the activity hub. So we can precisely limit the view of the world for that user to be their data. Now, if they need an expanded view, we can do that too as well, but we can start and default with their view of the world. That's a first order logic approach. Those will typically show up in the connectors and the tools. They'll certainly show up in perhaps even some of the agents where you'll do a bit of procedural code to monitor and make sure things are working well. End user feedback, I'm going to put in, because we do get a lot of rating of users, thumbs up, thumbs down, as well as feedback in other ways. I call that first order logic, meaning it's coming from humans. They're using their logical part of the brain to give us some feedback. But there are probabilistic approaches to regulation as well, and that's where the LLM itself is helping with the regulation. And so when agents are going back and forth with an LLM to solve a particular problem, That's a form of regulation. They're trying to find a good answer that's going to fit within the bounds of what is acceptable to the user. And of course, our inline and out-of-band safety checks also are probabilistic approaches. We think our future for the next 4 or 5 years is going to be solidly in both camps. I don't think we can avoid first order logic. All of our external software, enterprise software, is filled with oodles of it. Here's an interesting concept that comes out of this. And this is a researcher, Luc Van Loon, who has done some interesting stuff to monitor protein synthesis in the body by giving cows food in which amino acids have an isotope attached to the molecule. That milk then gets digested by the athlete, and they can trace that amino acid all the way through the cow, the milk, the human, and then the muscle in the body. So they can totally trace molecules through this whole thing. We can't do that today in AI. We could. It would require something like a large concept model. It would require some structure to the knowledge fragments in which we can tag knowledge fragments in terms of who owned them, where they came from. So you can automatically see the IP regulation potential here. And we're starting to do that a little bit, versions of that in the early stages. But we hope one day that we'll be able to do this far better, and probably largely from an IP standpoint, intellectual property control standpoint. Let's see, I'm gonna skip this because I really want to get to a little bit on our data approach. We have many forms of regulation in the data approach as well. We can do all sorts of privacy enhancing features to protect student data, etc., within our Activity Hub architecture. So even below row and column context filtering, we got more advanced algorithms that can come out of the box automatic within it. Our safety approach is, again, we call that an ensemble of experts. We're using DBRX, LLM, C4 AI, Command R plus LM, Llama 3 family, whatever the latest is, GPT-4 actually, and we're probably switching some of those models out as I speak. This is a dynamic environment. For every week there's changes going on. And then we're using Llama Guard and Llama Code Guard. And what happens is we automatically, using NiFi, pull content out from the last period of time that I've been processing, put it against a rubric that looks at this from, various lenses like offensive statements, toxicity, exclusion, discrimination, etc. And then we let each of the models vote on how good or bad that particular input or output is. And from there, we then follow up right now with manual intervention, and likely for the foreseeable future. But I think in time we can see this becoming much more automatic, where in a way the AI environment is more successful at self-healing. This does not mean we take a human out of the loop, just the contrary. We will always keep a human loop to always evaluate the safety. Getting back to some practical matters here, this architecture is now being used in a variety of assistants. These are some of the assistants we have out. Some of them are actually, their fact retrieval is out, so it's not coming soon. That's actually here, but there's more enhancements coming to it shortly. But we have a UC San Diego assistant, which is our workhorse one. It processes all of our UC San Diego policies and procedures and help documentation. And it serves as a form of super search or answers to questions and some basic processing capabilities. We have an interesting one called job description. Yeah, can you discuss how you have created or mitigated things like discrimination, safety, party architecture? Well, that's the whole ensemble of experts. And along the way, what happens as you start to ingest your own content, don't forget, discrimination and bias comes from the content. So you have to go back to your content. So if you find errant content, you have to remove it or change it. So it isn't a magical thing directly out of the AI that appears out of nowhere. So we work hard, and we have worked hard over the last 2 years to scrub content. So garbage in, garbage out. And then the safety expert model is really how we get at the safety. And And if you look back at the slide, you saw essentially a high-level view of our rubric that's being used to evaluate the output. We have a job description helper, which helps people with creating a job description. It also helps them with tailoring interview questions, as well as writing marketing materials for the job. And that was met with tremendous applause from the crowd because a lot of people hate writing job descriptions. We have a general AI assistant, which it actually does not include the UC San Diego content and context. In some cases, we find users who want to interact with the LLM and the internet search directly as is without prioritizing our content. And that could be useful, especially if you're uploading a large document and there's not a lot of content within UC San Diego that's going to help you out. Oops, I advanced a little too hard there. Our fund manager coach is one that's out and it's helping people with answer questions on how to handle research, budget proposals, and transactions. We are in the middle of a work on a contract reviewer that helps our legal staff automatically highlight and suggest changes in contracts. So that's coming quickly. Our fact retrieval is out in the first version, and we got more revisions coming that's going to give even better answers to questions with a full agentic approach to interacting with our data warehouse environment.
Dr. Kellen, very quickly, I just wanted to point out 2 questions that I've seen in the chat. I wonder if this is a good time to ask those.
Sure.
Wonderful. So first, we have the UCSD. Does UCSD take a democratized approach to data? So, for example, deans might see other deans' budgets. If so, the access control might be simpler, but also political. If not, does Triton make the personalization of access control more efficient and effective?
Well, we can do any flavor you want, quite frankly. So we got different flavors of this, obviously. But let's step back a little bit. Just about all our financial and accounting data is public record information. All of our salary data is available on a University of California website for easy inspection by anybody. But it doesn't make sense necessarily to have everybody looking at everybody else's budget just from a context standpoint. It's too much context. Almost everybody is fixated on looking at their content. But within our data warehouse architecture, we have absolutely hierarchical row filtering capabilities. And so as you go up, the dean should be able to look at the content all below them, and so on down the line, or so on up the line. So we can accommodate any flavor of row and column level security. The big question for institutions is how far do you go? Because you will bury yourself in your rule sets on how to divide access up. And when it comes to student data, where a particular department might need to see access to student performance outside of that department. So chemistry may be very interested in student performance in math tests and math classes as a critical element for advising and helping that student. So that all depends on the policy for each institution, but within our environment, we got more than enough tools to kind of provide any flavor of this that we want.
Thanks so much. And we got another question. Can you discuss how you have created the mitigation for things like discrimination in the safety part of your architecture?
Yes, and if you look here at the safety architecture, you will see we have what we call extendable safety dimensions. It's essentially a rubric that we worked with one of our faculty members who's an expert in this area to establish ways of evaluating input and output to the system and flagging that content based upon this. So this is our ensemble of experts safety approach for evaluating LLM safety. So if you look in here, you see a number of concepts that hit on that category. And it's not just that, it's information hazards, malicious uses, discrimination, exclusion, toxicity, offensive statements, bias, misinformation, harmful interactions between the human and the AI, criminal planning, regulated or controlled substance questioning, self-harm, illegal weapons, et cetera, et cetera. So that's how we're getting at the continual evaluation of the safety environment independent of the AI company.
Thank you. And just one, got a couple really quickly, and then we'll get back to the rest of your presentation.
Yep.
Really quickly, how have faculty responded to this AI tool on your campus?
The general response is, how come we didn't know about this sooner? No, faculty, we got a faculty that, likes to lean into the future. So we're going to talk about some faculty use cases of Triton GPT. So we've had some faculty do some good work with it. By and large, faculty are eager adopters themselves, even in the coursework. Of course, there are some faculty who are going to say, I don't want AI anywhere in my coursework. I don't want to go near it. But I would not say that's the dominant viewpoint at our campus. I think there's more confidence in our faculty in approaching the AI on that standpoint. And we've made presentations to our faculty senate. In fact, right now at this time, rather than me giving the presentation, my team's giving a presentation to our academic deans on how we're going to deploy access to students to the environment.
Got you. And then kind of going in the same vein there, you've been talking about the presentations you've been giving, but have you found a need to create some prompt cookbooks or some
Yes.
support materials to help users interact with the agents and chatbots?
Absolutely, and that's a nice segue into my next section here.
Amazing.
How do we engage the community? We've created two approaches. One that's tailored to the academic side that works kind of within the academic realm for how to do the academic teaching side, and then one on the administrative side. Now we're about to bring those two closer together in the next year, but for expediency, we kind of split them off. And on the administrative side, we have this community of users, and they submit ideas for us to develop solutions that they can't develop on their own. And so pretty large community engagement on that that's been going on for the last year and a half. Here's a real simple example of an intake form that comes in. Someone says, hey, I have an idea. They describe it. They give it a description and a title. They do some basic rankings of it. It produces essentially a charter that looks kind of like this. It describes the particular solution, describes the impact, etc. And then this gets shared with that group of community. It's actually a work group. And they come together, over 20 participants across campus, including the academic areas, but mainly on the administrative side of life. And they review those, help prioritize, and give some feedback to it. But also, we have community of practice sessions going on, facilitated by both us and a group on campus called our Office of Strategic Initiatives. They do a lot of Lean Six Sigma development and analysis and training. We're a very strong Lean Six Sigma university with thousands and thousands of Lean Six Sigma trained people in the institution. So there's been a rich community of practice that shares these prompting books and prompting techniques. We got some training materials out there that we're going to grow, mainly videos that have been developed that people can look at to learn. And yes, a big focus for us in the next 2 years is, in order to democratize access, you have to get better knowledge about how to use the AI. Our own analysis of our usage is showing that the majority of users, 80%, tend to treat the AI as a replacement for Google search. So their prompting is at about that level of sophistication. We need to raise that level of sophistication to get the better usage out. At the same time, we want to raise that level of usage. We're also trying to build agents that are made for very specific business processes. So you can think of growing adoption bottom up through better awareness, knowledge, training of people, and peer interactions with people so they can grow and develop their ability up. But also from our leadership community on down on, hey, we're going to create a fund manager coach. We're going to create a job description helper. We're going to create a malicious email analyzer tool for you. And so that's a way of top down. It's a way of getting the AI kind of ensconced within a business process itself. Both approaches are going to be important. So yes, we've had some strong community of practice work over the last year and more to come in the next year or two. I'm going to plow ahead. This is our kind of at a glance where we're at with certain things. We got some things in consideration. One of the reasons we're hitting the streets right now on explaining how we want students to access this is we want students to get access to, basic information like, where places on campus they can go for help. where's dining on campus? How do I get from here to here? So think of it as student one-stop shop type question. And so we can think of the AI platform now as rather than building a website for a one-stop shop, you can build an AI assistant for a one-stop shop. And that can integrate content across a diverse number of websites, no matter where they are. We've got many components under the hood that we're working on that are listed here. I think, obviously additional connectors have been built and are continuing being built to connect to systems. We have a dining assistant that's going to help people with analyzing meal, including macro and micronutrient content within the meals they get on campus. We will be offering an image analyzer assistant. We've kept it in abeyance for a while, but it will come out in the next several months. We have another way of protecting IP called stained glass encryption from a company called Protopia. This ensures that if we have any dialogue sessions or image or content uploaded into the environment, it is put through a non-reversible one-way encryption technique, which now makes it forever human unreadable, but readable by the AI. So it takes a human readable knowledge fragment, converts it to an AI readable knowledge fragment, for which the human can never read it again. It doesn't affect the AI performance. It only does a little bit maybe negative or a little bit positive. It's the concept of introducing noise into an LLM. And that's a very key intellectual property protection tool that we want to have available to us. It also enables us to safely submit content to a third-party cloud-hosted AI platform, knowing that that platform can't really make sense of the content we submit it. The inline safety is what I mentioned we're working on. And this notion of dialogue caching, try to take those knowledge fragments in the dialogue, cache them, store them, save them, to help improve the quality of the performance. That's kind of in development now. We got a number of things that are already out there in use, as well as several components. And we're recipients of a $1.5 million grant with our San Diego State University to pursue some academic use cases here. I'm going to pause. Oh yeah, tutor integration with Canvas. Funny you should mention that. Let's go next. Within our instructional pilots, we have a faculty member here, Dr. Sesh Murphy, who has created basically a Canvas plugin that plugs into Canvas, uses our Triton GPT to help develop assessment questions and provide context-specific student feedback in Canvas itself. We're doing a test with 2 courses right now, and we're going to watch it and see if we can scale it out to whatever course wants to use it. Subject matter experts remain in the loop at validating the LLM-generated content and accuracy, obviously very important for coursework. So that looks very promising, and that was also a recipient of one of the state grants for AI. And then we have another faculty member who's going to kick open Triton GPT access directly for the students in an educational context to help students generate learning materials appropriate for varying K-12 grading in support of teaching a specific lesson on how generative AI is changing society. So they're using generative AI to teach generative AI. Very interesting approaches. This one, probably not quite a Canvas plugin, but this plugin will be very important because you can just cookie cutter this across different tools within Canvas. This is also part of our collaboration with SDSU, and that grant is how SDSU will be creating very course-specific things similar to what Dr. Sesh Murphy is doing and probably borrowing some of the same techniques we're using there. I'm going to pause here. I'm getting right up to my 45-minute. I'm going to end with a couple of things here. One of them is we've been really thinking about what is the future for development of all these tools, given this metabolism of knowledge that's creating knowledge fragments everywhere. And knowing that the speed and the variety of those knowledge fragments coming at us can be quite fast. And so we're trying to move to daily development, testing, and deployment. Continual delivery, essentially. We're not quite there yet, but I suspect in the next 2 years, we're going to be very close to there. So rather than thinking of this as the formal, we're going to do a pilot, we're going to do development, we'll do some testing, we'll do a pilot stage, and then we'll, roll out from there. we're thinking of this as a solution that starts out with a small audience, and the audience just merely increases with every iteration. And those iterations can be daily, weekly, monthly, quarterly. In fact, many of them are daily in the early stages. So this really changes our notion of how we run an IT shop to develop solutions and deploy them across campus. So we're thinking about AI ops as the successor to DevOps. And I think the feature is going to be continuous delivery, controlling audience size either upwards or downwards based on quality and monitoring, and then continuously adding features, perhaps daily, weekly, throughout, the course of our terms in our year. Along the way, we've done some collaborations with other universities and doing some more who want to take advantage of the approach we're taking. And so our collaboration is again focused on democratization of access, being extremely affordable. But what's really interesting is we're finding through a very small team, because up until recently, our team size was 4 FTE, 2 regular IT employees, and then a group of about 4 part-time students underneath them, the equivalent of 2 FTE, doing all of this work. We've now expanded it by another 2 FTE. So we still have a very small team on this. And we're amazed at how much this small team can do, especially given all the news you hear that you can't possibly do this on your own. You have to use a big solution from a big provider. I think that's bonkers. I think the availability of all these open models all over the place are lowering the barrier for everybody. We are seeing that. And for most mundane applications, you don't need the big expensive models. You can work in your locally on this. And I think more importantly, with the model captive in our environment or captive to our collaborators, to them, they can then start to tailor and tweak and modify in a way that is very custom and proprietary and competitive for them. And this is just a list of some of the collaborators that we're doing and some of the topics we're trying to get on additional collaborations, which might return into either investor funding or extramural funding of some kind. And with that, I'm going to stop here and leave it for questions.
Thank you so much, Dr. Kellen. This was really, really exciting to see the work that you've been doing. We would love to see more questions, either in the chat or in the Q&A feature, please.
As that comes in for both academic and administrative uses, teaching and learning and administrative and research uses, I think AI is going to be the dominant application development paradigm. All the ways we used to develop applications will begin to fade away, and we'll be doing everything in an AI sort of mode. Not everything, but good 75% plus in the coming years, 5 years, 10 years, but certainly in the future. Well, thank you so much. Hopefully this was helpful.
Yes, thank you. And as questions come through, please feel free to throw them into the chat. I guess, kind of bringing up that point of, this is going to be growing and continuing to have a major impact on, the way that technology works in higher education. What do you say to those who are still feeling daunted or not really sure what this will look like, or feeling a little bit more complicated feelings about generative AI?
Yeah, and you think of it this way: when students come into a class, let's say Calc 1, guess how they feel coming into the class? The same way you feel coming into AI. So it really now is how do you educate yourself? How do you gain confidence? There's all sorts of certificate programs and coursework out there at large. Certainly take advantage of it. Begin your self-study on it, especially if you want to be an active participant in the creation of AI applications. So.
Awesome, thank you. And we got a couple in the chat. I think you see
that. So what access students have trained? Right now, student employees have access to TrainTV, and there's several thousand of them. But we're going to open up regular access, and mainly it's to help them navigate the administration of the university. So one-stop shop for student help. That'll be the first case. And route them to key resources on campus that they might not know how to get to. And we've got one here. What was the one after that?
We've got focus. I know you were focused on the AI architecture, but can you comment on faculty's concerns about student uses of tools regarding academic integrity or how it's impacting adoption by faculty?
Yeah, cat's out of the bag. Students have access to it whether we like it or not, so they can get the free versions and but you're going to find that students are fitting that same Pareto distribution of usage. A few will really take advantage of it, some will not. I think our role as faculty should be helping teach the student critical reasoning skills, which are most at risk, actually. People who have there's actually recent research out of Microsoft, and this just popped out today. If you have high confidence in your approaching to the AI, you're more likely to exhibit critical reasoning skills. If you don't have high confidence, but you are trusting the AI, you're more willing to outsource your critical reasoning skills. We don't want that. We want people to exert their critical reasoning skills at all times. So making sure that you have the requisite knowledge about how this works and give yourself learning time to learn it is part of it. Getting with peers who can help explain this. So it's find the confidence in yourself to face the AI. It's over. It's out. Cat's out of the bag. We're not putting that genie back in the bottle. So now it's just how do we adjust to it.
In a similar vein, we have a question coming from the career counseling and advisory perspective. So we're having that conversation about what are the skills that are important for students to develop.
This is what I call a more profound use case for which, the AI can help a student get some basic understanding, but the deeper insights are probably going to come from human-to-human interaction. And so I don't necessarily want the AI to replace that human-to-human interaction. And I'll put it this way, the student who is highly confident in their use of AI and has super high critical reasoning skill probably can use the AI for all sorts of career counseling advice and probably requires less of our time. Not necessarily true, but in many cases that might be true. So I think the way I would position it is use the AI to take care of the mundane and the well-known, and then reserve the human interaction for the profound and the difficult. And that's the way I would tend to think about it.
It's a really good way to frame that. In terms of having conversations within an institution, how would you recommend exploring how to build your own AI architecture when you may not have the technical expertise in-house?
Yes, and we're discovering you need one person with technical expertise. That's it. Some of our best workers have been students. We had a student coming out of cognitive science who is now on our team. And so they might have had some technical training as part of their cognitive science background, but they're becoming very adept with the AI. So the AI is lowering the barrier to entry for people to do productive work. You don't have to be a programmer. In fact, we've been using this concept of concept to keyboard. Programmers have the muscle memory and the memory in their brain of how to take a concept and immediately produce code. If you're going to use an AI to do that, you're not doing that. You're explaining the concept to the AI, and the AI is now writing the code. So the concept to keyboard is greatly enhanced. You're outsourcing that manual keystroke entry and the retrieval of the specific facts related to that to the AI. However, you have to be in command of the concepts. And so what that means is you can probably find ways of getting staff you hadn't thought of. In fact, we've been thinking about this in our own IT team. What are the skills we need in the future given this environment? And so I would say start with just one technical person who kind of knows LLMs at a technical layer, but then immediately look for student workers if you don't have availability of talent who just seem to really lean into the AI and or other employees or faculty who really lean in and want to be AI whisperers. And yes, that is the article that was referenced.
Great. I'll be sure to snag that out of the chat and include it in our email to our registrants following up this webinar. We've got a little bit of time. Do we have any other final questions? Maybe perhaps from some of our partners. Anybody, any final thoughts?
I'll leave with one final thought. I think I'll leave with a metaphor. We're at the beginning stages of the terraforming of knowledge work across the globe. And when you come to the academy, we have some of the most intense and complicated and diverse knowledge tests. So think of our learners as extreme skiers. We want them to apply the most amount of cognitive effort they can muster, almost to the point of exhaustion, in order to learn and become really good. So we have students who are extreme knowledge workers. We don't necessarily acknowledge that. We got to acknowledge that. It may not look like it to them, but some of them fit that category. We have disciplines in the academic side that are diverse and many. So if you want to terraform or change all these knowledge tests, I'll use a metaphor here. On my property, I've got a grapefruit tree and some olive trees. My grapefruit tree, I can go out there with a basket and pick in 10 minutes a bunch of grapefruit, fill the basket up, go back to the house, in another 10 minutes, juice them, and be having grapefruit juice. When I go do olives, I take that same basket, and I'll be out there for 6 hours, and I barely fill a third of that basket. I then have to clean the olives, brine them for a week, replace the brine, and brine again for a month, and repeat for another 2 months. And then I can start to eat 3 olives. Automating and terraforming knowledge tasks is more like picking olives than it is picking grapefruit. And higher ed is ground zero to that complexity, especially in the academic disciplines. What works in geometry may not work in political science, may not even work in calculus. And so I think the art of constructing all of these tools around the AI, I think the AI over time will get better and better at accommodating more and more of these, but not all of them. There's way too much variety out there. So we're gonna need a lot of tool development and application development.
That was an awesome metaphor to end with. I'm very hungry. Dr. Vince Kellen, thank you so much for your time. It was wonderful to learn with you today. And thank you again to our partners for this series. Thank you all to our attendees who joined us today. If you enjoyed our session, please check out our next session coming up on March 12th with Dr. Nit Potkalitsky. We also have an exit survey for our attendees. We highly encourage you to check that out. This gives us some good feedback on what we can do in future sessions. So once again, thank you all for your time. It was wonderful to learn with Dr. Vince Kellen today, and we hope to see you next time.